I'm talking about my astronomy, but I'm talking about doing it in the way of seeking support. And this is a kind of research in and of itself. How do you get support as an independent astronomer while I'm jumping to a new project, because I graduated in nuclear physics and now I'm doing something with extrasolar planets. I've been doing that for several years, but I've done a more theoretical, data-dependent project. So I'll switch from this Kepler-Ori and start the slideshow. That Ori is rather interesting. What it represents is all the Kepler planets and having a relative speed of the planets going around. And so it's very interesting that we found, besides not counting the Kepler planet candidates, and the Kepler planet candidates are not confirmed, but I'll mostly refer to them as candidates. But besides that, mostly from the ground, we found recently we passed the number of 1,000 planets. And so I'm going to talk, my research project comes partly because there's so many planets. While 1,000 is not a very important number in and of itself, it makes a big difference to have 1,000 rather than 100 planets. And my research project is planets disappearing into stars. And okay, this is sort of, well, it doesn't have much of a light. I guess I will have to point. One of the first major planet to be found, 51 Peg, was found with a 3-day orbit. And that was one of the big surprises of planets in the very beginning, is that these planets in other solar systems, that some of the planets are very close to the star. And they were the easiest ones to be found. But as people started finding planets that have 2-day orbits, 1-day orbits, they wondered about these planets. How could they be in such short orbits? Because if you calculate the tides that are raised by the planet on the star, you calculate that these planets should be taking, the tide should be taking so much energy out of the planet's orbit that they should be falling in. And so my research is about planets disappearing into stars, but I want to go back a little bit into my history of my history of doing planet research, and say that I'm using this research as an objective to use public speaking to accomplish a major career goal, hoping for some way of going to the American Astronomical Society meeting in Washington, D.C., the AAS here. I'm not getting any light out. And then trying to, I've been relying on my savings, but I'm hoping for some support. Just like I've heard of $1 million prizes. I've attended talks by $1 million prize winners for people who've already done great, wonderful research. I think I'm close to finishing research. I've been told that my work is very good, and I just need to do all the statistics, do all the writing. And so I'm searching for a way, besides teaching English in Hong Kong, of lasting a few more months. And so I'm wanting to produce a product of speaking and writing to raise, as a means of participating in exoplanet science. And perhaps for something I could do in the coming year, to repeat my 2009 nation speaking tours, what I called, when I had a very early version of this project, and I actually drove from Los Angeles to Massachusetts and all the way back, giving some talks and presentations along the way.
How did you happen to pick Salt Lake?
I grew up in Utah. I'm a native Utahn, graduated from Woods Cross High School and from Bountiful.
Yeah. My memory is 30 feet or 30 seconds.
Well, no, I didn't say that. I appreciate that. That was a good question, and being a small group. Feel free to ask important questions, because as I practice my talk, I'll improve on the presentation. Just a few things that I've been told when I practice this in Toastmasters, a few points that people want to brought up in the very front that need some explanation before I just dive into the details. I talk about space-based planet-finding missions and ground-based planet-finding missions. And this space-based planet-finding mission that has found the most planets is NASA's Kepler mission. The European Corot mission has found a few. The ground-based planet searches, they've had longer to find planets. They've been finding them since mostly 1995, excluding some very interesting, very strange planets found before 1995. So if you forgive us for saying that 1995, the first planet, well, that we've been finding planets since 1995, other than the 1992, we found some pulsar planets. So my history earlier on with really working on a planets project, I did do some astronomy here at the University of Utah. That's another reason I'm here, and at Georgia State. But I had the chance to be the first staff astronomer at a private observatory, a global telescope observatory, and here I am in Hawaii helping with, we actually did mechanical putting together work of the telescope, refurbishing it, and I was the lone astronomer on the mountain when we actually had some fires come up the mountain. So we've had some dramatic times. We weren't too terribly, the fire wasn't going to burn the telescope because there's nothing to burn there, but we were pretty worried about what the smoke can do. So the Kepler mission, to start talking about actually finding planets and how did we get the statistics of 1,000 planets plus. And I should mention the thousands of Kepler candidates. I think it's above 3,000 Kepler planet candidates. The reason we call them candidates is that there's false positive mixed in. When you have a transiting planet, it's very hard to tell the difference between a transiting planet and a diluted eclipsing binary. And by that is, if you have two stars that are in eclipsing binary, if you happen to have a third star that's somehow reducing the light, you can reduce the level of transit to what looks like a planet. So any transiting planet, in fact, most of the ground-based searches, I think that you'll hear ratios of, there's like 2 to 1, 3 to 1 false positives on ground-based searches. The Kepler spacecraft here, it has such precise shapes of the transit curves that they're able to tell the difference. And by a transit curve, what I mean, I should back up. A planet transit is, in our solar system, Venus will transit the sun. And the difference between a transit of Venus and an eclipse of the moon, the only difference is a matter of magnitude. The eclipse of the moon just covers the sun. And that's cheating because the moon's sort of cheating because it's so close. Venus is getting not quite what you would see if you were light years away. But still, if you're outside during a transit of Venus, you obviously can't tell the difference. It takes sensitive equipment to to detect the reduction in light. And if you want to get really sensitive measurements of stars, having big planets transit, planets bigger than Venus, then it's very difficult to do from the ground, and we've had a lot of success from the ground, but if you really want good curves, you really need to go into space.
There's a lady in Kanab that
Oh, yes.
she's got 6 or 8, I'm not sure. I can't come up with the name. Her husband's Jerry.
Is it Kathy? I think
I
she's got like a 24.
Could be Kathy, but she's got 6 or 8 confirmed of her own.
I think she does confirmations more. She helps with confirmations more than she discovers them. Because
I think she's credited with at least 6 discoveries. Something like that.
well, what would happen?
And I don't want to interrupt your talk.
Well, it's an important point that validation and
Yeah,
confirmation
she's just an
versus.
individual, but they have a
Yes.
very exotic.
I've seen her name up and it's slipping my mind. She works with Bruce Gary, I think. Bruce Gary helps with
I
they
believe
collaborate.
that's correct.
And so what you have to do with all these planet finding, well, the next slide actually shows she's probably helping with this one or another one. She doesn't have this. This is a planet finding optimized, these are either small telescopes or actually just big cameras. And the reason you have 8 big cameras rather than one large telescope is to cover a large area of the sky. But these produce really lousy curves. And so what they'll do is they'll take the lousy curve produced by this, and they'll tell her, Kathy or whatever her name is, can you look at these? And she will get a much better transit curve. And so that's step 1 in the confirmation. Now I doubt that she's got spectroscopy to do a radial velocity measurement.
I can't tell you, it would not surprise me if she does.
Those are usually the big professional to have an actual spectrograph. Her niche really is to do that mid-level transit verification, that it's a good transit. But for the ground-based curves, you just can't get a good enough curve to be absolutely sure unless you do this other method of you look for the wobble, you look for the radial velocity wobble, spectroscopic, the basically